Hey everyone, and welcome to This Explainer. I am so thrilled you're joining me today because we're tackling one of the absolute most fascinating and frankly consequential topics in tech right now, artificial general intelligence, or AGI. I mean, everywhere we look, it's just headlines about the newest, most massive language models. But you gotta wonder, is simply scaling up these giant neural networks really the path to true AGI? Well, according to leading researchers, the answer is a resounding no. Reaching AGI is less about building one giant isolated brain and much more about creating a complex, interacting cognitive ecosystem. So today, we're going to walk through the exact roadmap of how we actually get there. We're exploring the 8 distinct stages of cognitive evolution that'll take us from the chatbots of today all the way to a fully autonomous digital mind.
Okay, let's dive into this evolutionary ladder. We'll be starting with 1. Beyond the giant model. Then 2. Memory and world building. 3. The multi-agent ecosystem. 4. Self-correction and growth. And finally, 5. The closed-loop mind.
Section 1. Beyond the giant model.
So, to really understand where we're going, we first have to ground ourselves in exactly where we are today, right? We are in the era of foundation models. Think companies like OpenAI, Google DeepMind, and Anthropic. And the contrast between what these current models can do and what they absolutely cannot do is pretty stark. On one hand, they are phenomenal pattern learners. I mean, they've mastered human language, they write intricate code, they've got impressive logical reasoning, and they even possess multimodal understanding, meaning they process text, audio, and images all at once. But their limitations are profound. They have limited persistence, there is zero autonomous long-term operation, and they possess very weak world state tracking. What this means in practice is that while current AI is incredibly powerful in short bursts, its intelligence essentially resets every single session. You can have this brilliant, deep conversation, close the window, and boom, the AI entirely forgets you existed. It can't independently manage a project over 3 weeks. That is the massive hurdle we have to overcome.
And this brings us to stage 2, which researchers define as the agentic layer. This is the absolute cutting edge of what we're starting to see today with agentic AI. Instead of just generating text, we add a layer where the model can reach out into the digital world. It searches the web, executes the code it just wrote, uses APIs to trigger other software, and strings together multi-step tasks. But here's the crucial point. Giving tools to models is a massive step forward, for sure, but it's still just the very first layer of a much larger puzzle. And agentic AI can book a flight for you right now if you ask it to, but it isn't a continuous, persistent intelligence.
Section 2. Memory and world building. To move from a system that just does isolated tasks to a true digital mind, we have to build the persistent blocks of cognition. Think about how you operate in your daily life. As humans, we rely heavily on accumulated memory. Every single decision you make is informed by what worked yesterday, what totally failed a year ago, and who you're interacting with. Stage 3 is persistent memory. The system has to natively remember prior experiences, successful strategies, deep user preferences, and the shifting states of its environment. Because without this accumulated memory, an AI remains stuck in a constant state of amnesia. Imagine an assistant trying to help you run your business, but they don't remember a single meeting you had yesterday. Yeah, not helpful. For an AI to be genuinely intelligent, it has to learn from its past interactions continuously, rather than starting with a total blank slate every time you hit enter.
Now, what's really interesting about this is how Stage 4 takes things even further into world models. Many researchers consider this absolutely crucial for AGI. A world model means the system builds its very own internal representation of how reality actually works. It understands the physics of physical environments, the intricate logic of software systems, the nuances of human behavior, and even complex economic systems. This leans heavily on model-based reinforcement learning, which is basically a way for the AI to learn by simulating outcomes internally before taking action in reality. And why does this matter to you? Because an AI with a world model can actually plan before acting. It simulates a scenario in its mind to predict an outcome, just like you'd imagine your driving route to work before you even grab your keys. It shifts the AI from just blindly reacting to intelligently anticipating.
Section 3. The multi-agent ecosystem.
Once we've got memory and world models locked down, we have to completely shift our mental framework from a single, isolated thinker to an entire society of agents. The old paradigm is the single thinker approach, relying on one massive model, and honestly, it suffers from limited checking and constrained scaling. If that single brain makes a mistake, the whole process just fails. But the new paradigm, multi-agent cognition, this is where the real magic happens. Instead of one thinker, imagine an ecosystem that acts a lot like specialized regions in the human brain, or different departments inside a massive company. You've got agents acting as researchers, other agents checking for errors, and others handling the final execution. The benefits here are just massive. You get parallel reasoning, rigorous error checking, dynamic scalability, and incredible robustness. It's basically teamwork, but executed at the blistering speed of software.
Section 4. Self-correction and growth.
An intelligent ecosystem still isn't AGI if it's frozen in time, right? We have to make a crucial evolutionary leap where the system stops being static and actually begins learning autonomously. Right now, foundational models are mostly static after they finish their massive, incredibly expensive training runs. Their knowledge literally cuts off. Stage 6 introduces continuous learning. A true AGI likely requires a system that acquires knowledge from its experiences continuously, on the fly, every single day. It absolutely shouldn't have to wait for engineers to kick off a new multi-million-dollar training run just to realize the world has changed or to learn from a dumb mistake it made yesterday. It needs to learn by living, exactly like we do.
And this brilliantly illustrates the leap to stage 7, metacognition. This one is profound. Metacognition means the system can actually reason about its own reasoning. It pauses and asks itself, wait, was my conclusion reliable? But it goes even further than that. It asks, what evidence am I missing right now, or which strategy is actually going to work best for this specific problem? By doing this, the AI creates an internal self-correcting loop. It's no longer just confidently spitting out an answer, it's auditing its own thought process, catching its own hallucinations, and refining its logic before it ever presents a result to you. Which leads us straight to the absolute pinnacle of our evolutionary ladder, stage 8, recursive improvement. This is widely viewed as the final step before AGI, or honestly the threshold of AGI itself. This is the stage where the system is intelligent enough to write better code to improve its own core algorithms. It literally learns how to make itself smarter. But the monumental challenge here is making this process stable, safe, and genuinely effective. You have to ensure that as the system rewrites its own capabilities, it doesn't accidentally break itself or deviate from its intended, safe alignment. Overcoming this specific technical hurdle is basically the holy grail for AI researchers today.
Section 5. The closed-loop mind.
So, we've climbed the 8 stages, now it's time to put all of these pieces together into the candidate AGI architecture that researchers believe will finally bridge the gap. Let's move to and see how this builds into a cohesive, continuous cycle of cognition. Step 1 integrates persistent memory and world models to allow for deep strategic planning. Step 2 uses those plans to make predictions and take decisive action. Then Step 3 takes the results of those actions, whether they were huge successes or total failures, and feeds them directly into metacognitive feedback and continuous self-improvement. This is not a straight line, folks. It is a closed loop. This cycle operates continuously in the background across a ton of different domains, requiring very minimal task-specific engineering from us humans. It's an engine of thought that completely powers itself.
There is a core takeaway from the source material that I really want you to remember. AGI may emerge not from a larger language model alone, but from closed-loop cognition. The sheer brute force of just pouring more data into a larger neural network is eventually reaching its limits. True artificial general intelligence requires a fundamentally different architecture. It requires the memory, the world building, the multi-agent teamwork, and the continuous self-correction we've just spent time exploring.
So we arrive at our final thought. AGI isn't just a single brain sitting in a cold server room somewhere. It is a persistent, highly adaptive cognitive ecosystem. It's a digital society of specialized skills operating in a continuous, endless loop of learning. When we view AGI through this lens, the incredible progress we're making today with agentic AI isn't the finish line. It's honestly just the ground floor. As these closed-loop architectures start coming online, the leap from where we are today to true AGI might happen a lot faster than anyone expects. The real question you have to ask yourself is this: are we ready to interact with an intelligence that doesn't just answer our questions, but remembers, reflects, and evolves right alongside us? Thank you so much for joining me on this explainer. Keep learning, and I'll see you next time.